All right. I see it. I don't know about anybody else.
Yep.
Right. Just make sure. Got to reload. 1 second. Hopefully everyone stays in there. The thing, it doesn't disconnect everybody. Okay, so basically what I'm going, well, let's take a look at the repo first. So what I wanted to do today was to basically get a chat bot up and running for people. And because I think that's like the first thing that you should learn how to do when if you're deciding to do like machine learning and like running models yourself, because the chatbot because then unlocks the ability to ask it any questions that you might have, and it will help troubleshoot problems that you run into while you're working with LLMs, all the way up to like running vision models and everything else. So I found ChatGPT has been a very good and terrible mentor. It's all just dependent on you got to make sure that you're taking it all with a grain of salt. But yeah, so the easiest way that I found to do that is to run the Llama CPP library. So this is an implementation of a C, basically like bindings for the C language that is allowing you to interact with the low level parts of your computer, and then those allow you to run accelerated models that go faster than Python would normally allow, because Python has things that restrict you, like the global interpreter lock, as well as well, I guess mostly the global interpreter lock. It just doesn't let you do multi-threading or parallelization, whereas other languages like Rust and C and stuff will allow you to do that, but they're more complex in terms of managing the memory and other things like that. So this is sort of like an abstraction of all that, and allows you to be able to just like run it as if you were running it in that language, but you don't have to do any of the hard lifting in terms of actual implementation of the code, like the low level code. So Llama CPP library is at this address. I don't know how to say that person's name, but it's super duper useful. It has basically an install for every single possible operating system that you can think of, including a phone. So it doesn't really matter what implementation or like what hardware you have, as long as you have something like even just a CPU, you can still run some version of this. It just may not be like the latest and greatest and biggest and shiniest. But you can run it all the way down into like running things on Android phones and stuff too. So it's very robust. It hosts a large number of language models. So you can get your Llama 2s, Mistrals. Those are the main ones that I play with. There's a few other models. The older ones I don't really play with too much. I have trained a Mamba model and a Gemma model. Those are good as well. And the other thing that's really good with this is that it comes with a library that allows you to train and quantize models. So I'll show you how to do that as well. So it is definitely worth taking a look. Basically, when I figured out how to use this library, it like unlocked all of the language models for me. Even does multimodal like Lava and Baklava. So yeah.
Can you post that link in the chat?
Yeah,
I
sure.
can't find it on Git. Thank you.
Check. It works on Temple OS. I have no idea what Temple OS is.
I don't know what that is either.
But we could look. It theoretically, I imagine that they might have an implementation for it, but anyway, I'm not sure what Temple OS, but it does work on Mac, Linux, and then Windows, as well as there's Docker containers for it as well. So if you can run Docker, you probably can run this.
Do you know if it plays? Do you know if it plays well with like your M1, M2? You know, your Apple Silicon type processors?
Yeah. So the one thing with this library is they're very keen on making sure that it is cross-platform. So they've done a lot of work in terms of making sure that it does work with your Apple Silicon. So
okay, cool. Thank you.
yeah. So yeah, these guys are great. You should give them a star. Actually, I should give them a star. I've never given them a star. Now that I think about it, gosh, what a jerk. All right, okay, so basically, you could read all these docs. There's like a lot of docs. Basically, it explains how to install it in like a multitude of different ways. But the long and short of it is pretty much this. You git clone the repo, you go into the repo, and then you just make the repo. In this instance, we're using the H100, so we can use the CUDA version of it. So if we scroll down here, you can find there's a bunch of different kinds of builds depending on what your hardware is. And this is what really taught me like how wide and varied all the different hardware is and requirements, and the fact that this can run across all these different platforms is like a testament to how much work that these people put into this library, that that it functions at all. Because like I have a hard time running like WSL and like Linux, and that between the two is just like a nightmare. So I try to work on VMs as much as possible. Yeah. So we just need to remember this one basically. So the make llama, but that's all inside of the notebook. So we'll give this a go, and it sounds like we have an error that we're going to encounter, so that should be fun. Oops, this is something else.
Okay.
All right, so let's try this. So you can run the first cell. Python environments, sure.
Okay, what are you running in for your IDE there? That's that.
This is VS Code. I'm just really comfortable with VS Code.
Okay.
The Jupyter notebooks never really were a thing that I worked with.
Got it.
So, yeah, but so you run the first cell. Basically, what that's doing is it just creates a shell for you. It activates that virtual environment, and then upgrades your pip installs and sets up a couple of basic setup tools for the pip environment. The next one is going to set your CUDA visible device, and so that will basically, I'm just setting it up so that only one person can use one machine, one card at a time, because if everyone tries to use the same card, it'll just fill up right away.
Okay.
So we can do video
Now, when I went to the the Iron Python notebook, it launched its own environment in there.
Yeah. So I just tend to make a venv anyway. It's like a lot of people do CUDA. Not CUDA. What is it? Conda. It's the same thing. You don't technically need to do it because the Jupyter Lab does make its own like little environment, but it's like a good habit to get into, so then you don't accidentally break your computer, because you'll find that every single machine learning library has very specific and exact requirements, and they do not work with any other bloody library.
Oh, okay.
Yeah, so it's a very, very common problem to, like, if you start installing things, like if you never use virtual environments and you just keep installing things in your computer, you will mess up your computer. And then you'll probably have to like wipe all your Python stuff off of it and then restart it.
Okay.
So yeah, good habit to get into.
I did,
yeah.
when I did run it though, in the notebook thing environment that they have, it seems to run just fine. So just different. Looks different, that's all.
Oh, NVCC is not found. So that means that I need to install NVCC. So go sudo apt search NVCC.
Is that something we'll all have to do then, or?
It's basically comes, like, I could do an entire class on how to set up CUDA, because like it's super annoying. If you want to keep up to date with,
I'm just wondering, as we go along then, are we going to have to follow these?
This is like a global install, so it shouldn't. Nobody else should have to do this.
Okay.
Oops, I didn't actually put in the right thing. So.
Well, thanks for taking the bullet then on that one.
Yeah, no worries. This is fighting with CUDA is like basically my job. NVIDIA CUDA. Do I not have it? NVIDIA. I don't have the CUDA 2 quit installed. Okay, so then I probably have to run my big giant script.
Well, we'll let you set it up then for all of us, so we don't have to do it individually.
Yeah. No worries. It should only just take a sec here.
Okay, cool. Appreciate it.
but we already got the library downloaded. So basically what this is doing is it is downloading this folder here. And this is the library from the Llama CPP library that I was showing. And it will use the make builder to build all the different things that are available inside of it. So there's a chat bot, there's a server that will serve the chat bot, there is fine tuning, there is training from scratch, basically everything that you could want to do. You just got to go into the examples and then build those examples, and then you can do all that good stuff. Okay, so we're installed now, so let's try this again. Architecture must be explicitly provided via CUDA Arch. Okay, fine. We'll give it CUDA Arch. So everyone's going to need to put in this one. So you put export CUDA Docker. Wait, CUDA Docker Arch. That's weird. CUDA versions greater than 11. CUDA architecture must be explicitly provided with CUDA Docker Arch. Okay, well, we are. Looks like we're 11.5, so.
So Richard, there's a question in the chat from David Sanchez if we're going to each be in the same environment or different ones. I believe the answer is, at least the old architecture was you installed the CUDA framework on the host, and then you accessed it via a gateway in the CUDA Docker. But I know that changed a couple versions back. What you're setting up is, though, still going to be CUDA Dockers can exist in isolation, sitting on top of a host environment. Is that right?
Effectively, yeah, that's correct. So the global install that I did, that's the global install. So nobody else will have to do that. But on this one, you'll still have to explicitly label the version of CUDA that we're using for the library, because it's just asking for it, I guess.
If I remember correctly, the Docker environment has to interface directly at a binary level, binary kind of communication protocol level with the host environment. And so that's why you have to have the version matches, is because that communication is literally kind of binary level back and forth communication.
Yeah, that makes sense. Because you basically are using the CUDA runtime. It's a CUDA Docker Toolkit is the name of it, but it's the CUDA Docker runtime. So it basically interrupts between the CUDA drivers in your machine and then the drivers that allow you to run accelerated hardware inside of a Docker container. And then without that, it doesn't know how to talk to the driver, or it doesn't, like, the container won't know how to talk to the drivers of the GPU accelerator, and it won't be able to talk to it. So we'll just, I think it's going to fight me on the CUDA thing, so we'll just get rid of the CUDA thing for now. So just delete where it said make, and then let's go back. This part that says Llama CUDA, just delete that, because I can figure out how that works, but it'll take quite a while to do. And we can actually just construct it without, and then the hardware is like crazy good, so it doesn't really make a difference. But CUDA is really good for optimizing your code. It's definitely something you want to spend time implementing and making sure that it works correctly. In this instance, I just don't want to spend, like, this shouldn't be a video of me messing around with the environment for 2 hours.
Yeah, I'm getting an error that says that, oh, wait, I think it's me. Never mind. Can you scroll back up there? I want to just verify. Export devices, export. Oh, you
So
you took.
it would be the last thing after make. You just want to get rid of that CUDA part, and then it'll run properly.
Okay. Well, actually, mine has, let's see, I guess I have 2 exports. Do I still want the Docker architecture?
No, you can get rid of that as well. What number are you in?
3.
3,
I believe.
Right. Here. Yeah. So you still want this part. CD. Oops. copy and make. There you go. That should work for you.
Okay.
So what this is doing is basically compiling the binaries that are running all the different features inside of the library. So as it goes through, it basically there's like a bunch of like C++ scripts that it's running in order to pre-compile all this stuff, which is one of the reasons why it goes faster. Because if you have something compiled, something as large as a language model, like pre-compiled before you actually try to run inference or train it, as much of as you can anyway, because a lot of it's dynamic and you have to make sure that the shapes of the data going in and out of it are correct. There's a lot of sort of nuance with that, but basically this is doing all that stuff without you having to figure any of it out, which is quite nice.
Could you go back to that file again? That line that you just put in at the top there, where yeah. So you CD'd then down to llama CPP and then ran, and then did the make.
Run make, yeah.
Okay. Key.
I have a question. When we run make without G, we're running without multi-core. So why not using, for example, more cores to make it faster?
You mean for compiling?
Yes.
Yeah, just because I didn't have time to figure out, I don't know what the commands are for it in order to tell it to use more cores, but when we go to actually run the language models, we are going to do that because I do know the commands there.
Oh, okay.
I just didn't know them off the top of my head, and I only have so much time before the meeting, unfortunately. But the compiling is done for me, so hopefully just let me know when everybody else is compiled up, and then we'll start
Okay,
playing
if you
around
could
with the
scroll
language
back up to that, Richard, that'd be great. I just want to double check my line. I think I'm
yeah,
off.
sure.
Is anybody else having issues with that? Is it just, I don't want to hold us all up here. It's just me being stupid.
Which script are you talking about?
There you go. All right, do that one. Try it now.
Yeah. Okay.
Oh, you already
I
have
see.
it. I see what the problem is. You already had the thing downloaded, so you just need to CD in and then make. Because this is saying llama CPP already exists, so it's getting mad at you because you're trying to make a directory that already exists.
Ah. Yeah, okay. Let's see about it now.
In theory, that should work. Anyone else having any errors?
I seem to be complete.
Sweet. Okay, then I need to find us a model. Let's grab Hugging Face, Mixtral. So I can pull up this while we're all installing things. So this is the Hugging Face repo for Mixtral of experts. It's 8 times 7 billion parameter models. So basically it is 8 7 billion parameter models that are all sort of bound into one model, and then effectively they they're not like explicitly chosen as like this one's an expert of that or this one's an expert of this, but they are they naturally wind up becoming experts in the way that they're being trained in whatever domain that they wind up. It's just sort of like dependent on the data and stuff. I'm not actually sure exactly how this works. Does anybody have any idea how that works exactly?
I can jump in just super briefly. It's only the feed forward layers that are split out into experts. So it's not actually 8 side-by-side models. if you know the transformer LLM architecture where you have an attention layer and then a feed forward layer, attention, feed forward. All the attention layers are just like normal Mixtral, but the feed forwards, when you run inference, there's 8 copies, so to speak, of the feed forward layer, and it'll only use, I think, 2 of the 8 on any, given prompt that you type in. For each token, it'll use 2 of the 8. But it'll use a different 2 depending on whatever token it's on. So that's the super short version.
Yeah,
So Ted, is there a small network that selects which of the 8 feed forwards to use? Or how does it select?
I'm trying to remember in the Mixtral paper. Yeah, there is, but I'm trying to remember exactly what it was, and I can't remember what they use.
Okay, not important.
But it's something really lightweight, yes.
Yeah.
You don't want it to be expensive.
There you go. The
I'm
router.
driving, I may not be too audible, but isn't there a gated something in that for the picture picture?
I cannot understand what that.
Sorry, your audio wasn't
Yeah.
very good.
Driving, it's raining. What I said is, isn't there a gated thing on the architecture itself, or maybe I'm missing something over there?
No, you're right. It's a gated network that determines which tokens are set to what experts.
Correct.
And then
Yeah. Thank you.
the router learns the gating over time, I
Right.
believe.
Yeah, so like basically it would have its own sort of loss function for where to route things, I imagine.
Yeah.
It's all, it's end-to-end trained, and so
Yeah.
But what you hope is that it'll be balanced, and so roughly each of the experts will get used a quarter of the time.
So then I'm curious if, like, say you had like a model that you want, because when I work with language models, I tend to narrowly scope their tasks. I don't like them being generalists as much because I find you get higher performance and higher accuracy. Is there like a way that you could like pick your 2 experts and just extract it from the model?
Well, so in the Mixtral paper, they looked at it, and you can see some slight patterns. So like if the token is one of the digits 1 through 9 or whatever, a lot of them will wind up going to particular expert or whatever. But it's not like super hard and fast. So you couldn't really do that, because maybe if you only picked 2 out of the 8 experts, all of a sudden it no longer has the one that handles the word the. And
Oh, yeah,
kind of
okay.
suck.
Yeah. Kind of suck. Yeah. Okay.
Yeah.
that's
But to your
being
point,
lovely.
regular Mistral might be a slightly smaller memory footprint, and if you're going to fine tune it on a very narrow task, it might do just as well, if not better, than Mixtral.
Yeah, that's what I find. I have the Mixtral is up as like a just generalist available endpoint, and it's good for like chatbots kind of things, but like when I'm trying to get it to execute tasks, I find that fine-tuned Mistral models work a lot, are far more effective, especially if you are making LoRa's and stuff for them. But which we can do. So yeah, so we'll download this model. So I think I should put it in a central spot for everybody and then link it to everybody's thing, so we don't all have to download the same model. So I'm gonna put it here. Let's see here. GitHub. Hugging Face. So git clone this. Does not exist. Git clone. Oh. Sudo apt install get LFS. So get LFS is the large file service that allows you to download models from Hugging Face. I probably also need to put in a Hugging Face token, so I will obscure my screen for a second here. Not that I think anybody can really do anything bad with a Hugging Face token. I guess they could like get a model and get you banned off Hugging Face or something, but token. Okay. Keep going. This. Copy this guy. Train. Copy that. All right, that's downloading. Should go pretty quickly.
Oh, I see.
And then I'll just link it to everybody's folder. So what we'll do is we'll do this. ln-s. It's going to be Mixtral 1, 2, oops, 3, 4, 5, 6. Glad I made these all numbers. This would be tedious if it was words. 8. Okay, that's it. Okay. Everybody see that folder in their instance? Then I'll work. I don't see the folders. Okay, that's weird. ln-s. And then I need to copy. It's from and then to, so it should work like this. 1 slash. Failed to create symbolic link. File exists. Okay, so this is just not up to date. And can anybody else see them?
I didn't see it.
No, I refreshed. I'm only seeing the Python notebook and the .cpp.
That's weird. Okay.
Did, but as a broken link.
Oh, is it broken link? Okay. Let me see here. So it is ln. Oh, I see what the problem is. 1 slash labs. That should work. Oh, let's do this. There you go. File exists. It says the file exists, but it's not there. I can, whatever. We'll just copy it. Everyone, you can just down. That's it. How much space do I have? Can I handle that? Yeah, we got 12 terabytes. We probably can handle that. So we'll just get everyone to download it. It downloads really. It'll download faster than it takes for me to figure out that linking things, and I could just clean it up afterwards. So just I put a command inside of the chat. So if you just run that command inside your folder, you need to put a exclamation point in front of it in order for it to go to the command lines, and you'll want to run it in a new bubble. So you'll put it right here like this.
The 19 safe tensor files are the model.
Sorry, I didn't understand the question.
You know that it download the files that say model.safe tensors.
Yeah, so that's the index of the model. And then there'll be other files that come in there, and those will be the weights and layers on the model. So the index, the model.index.json is basically just telling whatever library you're using to run the model how to assemble all the different layers of the model, if that makes sense.
Okay.
And it also will tell them like when to use the scheduler, and when to like, yeah. So yeah, you can see like here it's showing like the different like which set of weights to be running at what time, and then it will also do like the tokenizer and the scheduler as well. So basically, it's just sort of like a map of how to run the language model. So give that another minute.
I noticed when I ran the git clone, by the way, I'm Ryan, that's my first time on this meeting, so thanks for hosting it. I just noticed when I ran the git clone command, I got a fatal message, could not create a working tree, directory file already exists. I noticed in the Jupyter notebook that the file's not there, but
Yeah.
then I went into the terminal and did an ls, like the terminal session from within Jupyter, and I see it's there. So I guess it's just.
Oh, okay. It's just
Yeah.
hidden for some reason. Let me go and fix that. Hold on. So CD1 ls. Yeah. Okay. I see what you're saying. ls remove Mixtral. So nobody would be able to do that. Too many layers.
Yeah, I removed it in.
Yeah,
clone.
now it's showing there. Someone must have moved it.
Yeah, because it's a broken link, so the Jupyter notebook cannot load it, but the terminal can.
Yeah, I gotcha. I gotcha. All right.
There goes. You smoked it.
ln-s, and then this will probably work. So then we want to do /Mixtral, and then put that here, and then we go like that, and now we have that folder working properly. Okay, that's what I need to do. I just need to do that for all of them. So then ls. Oh, this guy's working, so we'll worry about that one later.
Wait, that was mine. Can you please do it? I will stop the clone because
Oh
I
yeah,
think
okay.
let me just stop the notebook, and you can remove that folder and make a link.
And then
Yeah, that will.
that one. Yeah, that one's good.
Thank you.
D3. Yes. Oops. Gotta be quick on the command line.
Very impressive command line skills. I would have.
Oh. I'm not as good as some people. I need to learn Vim still.
I've been putting it off for so long.
It's one of those like I definitely want to learn it, but also I'm kind of intimidated by it.
That's what's good about this, though, because we're all intimidated by a lot of this.
Yeah, but I mean that's the whole thing. Is the only way to get good at something is to suck at it. So you may as well just start sucking now, and then
start sucking. The sooner you start sucking, the better off you are.
Exactly. That's my philosophy on learning.
Yeah, that's cool.
I'm happy to give like a 20-minute hack session on Vim. I didn't know anything about it, and then took the Kubernetes certification a few years ago. And it's all timed, so you need to be very efficient with Vim editing files.
Really? They have you on like that hardcore of a time limit?
Moving to the end of the line, moving like kind of navigating text files. So I learned a lot of hacks with Vim, and I'm happy to share those on a future session.
Yeah, it'd be great.
I would love to hear that. Yeah.
Yeah.
Oh, wait. So they actually, what happens if you go too long? It just says, start over, or?
Yeah, it's time you have to deploy applications onto a Kubernetes cluster and confirm that they're working. And in some cases,
and I guess you have to do it. Oh, sorry. You have to do it quickly because of how much it costs, right?
No, because it is a timed certification. And so you have a certain number of exercises that you need to complete within that time. And you don't have much time to be navigating around in text files, changing things manually. You really, a little bit of Vim goes very far in terms of.
They want to force you to use it then.
Yeah. I thought it was necessary. Honestly, I felt like that learning Vim was a necessary thing in order to successfully pass that certification at that time. That was in 2020.
Wow. That's impressive. Yeah.
That's kind of hardcore though, the way they're teaching methodology.
But it makes sense. Like if you're an MLOps person and you're working with a Kubernetes cluster and you have 100,000 GPU or like 100 GPUs or 1,000 GPUs, like every second that ticks, that's expensive.
Yeah, and users screaming at you, not just management, but users going, "What's going on?" Yeah.
I understand they want you to be quick, but that seems like kind of a harsh thing if you can't pass the test unless you can just edit text files super quickly. Like, right? I mean, geez.
I mean, as a software engineer, I might use Vim maybe for 10 seconds a day when I'm pushing code, but other than that, I don't really use it.
Yeah.
Yeah,
Well, I guess you would, it
Kubernetes-
depends what you're certifying for then, right?
Yeah, it depends on the use case.
Am I done
Yeah.
downloading?
Yeah, with Kubernetes, it's all template files, so you're just changing the templates constantly.
Yeah. Cool.
Configuration files, right? That's all it is. The whole concept of Kubernetes is editing configuration files, so you're constantly making changes to those. And with the developer certification, you're deploying services, making sure that they can talk to each other, debugging things, and it's all, edits the configuration.
Yeah, still sounds pretty hardcore to me.
Oh, there we go. Okay. I think that was it.
But why do you why do you have to edit those files? I mean, isn't there a layer above that can help you deploy the changes quickly?
For this, no, I've kind of hodgepodged everything together. This is not like a proper ML pipeline.
No. I was talking about the certification, the Kubernetes certification.
Oh.
Yeah.
That's like the level of abstraction that Kubernetes gives you. So, you don't need to configure like the networking necessarily to get pods or applications to communicate with each other, but you do need to specify which pods can communicate with each other, and that's all done through YAML files.
Correct. Yes. No, I know that. So I have certification and things like that. That's why I was wondering why you have to edit those files rather than have a layer above which helps you manage them. So we can take it offline. So no worries.
Yeah.
Okay.
Richard, where are we at here? Are you?
We're just waiting for the last couple pieces of the model to download.
Okay.
It's going at 75 megabytes a second, so it shouldn't take too much longer.
Yeah. Okay. I just wanted to make sure, we weren't missing while we were, off in this little tangent, we were missing something key. That's all.
No, you're all good.
Okay. Thanks.
I think there's 8 or 9 pieces of it. I probably should have picked a little bit smaller of a model, but it will be downloaded pretty quick here. In the meantime, we could talk about the different things that we will be able to use here, and I can show you a little bit about how the Llama CPP repo works. So from where, I guess I should do it with a notebook. I'm very used to the command line. So from here, we can do, so this basically, this library is a CLI, so that's a command line interface, and it will take basically you'll hit a binary and execute that, and then it will take in parameters in order to tell it like what kind of settings that you have. So you can start out with we're not going to be llama.cpp, and then / and then it will be the server. That's not what we want. We want, which one did we want? It is the, oh yeah, it's main. So llama cpp.main, and then if you go -- help, then you can see all the different you'll be able to see all the different commands that come up here. And so this is the settings that you set in order to interact with the language model. And with those settings, you have a number of things that you can play around with. I want to view as a scrollable element. Sure. Yeah, there we go. So I usually will like print this out somewhere and have it like next to me when I'm working, because there's like a bajillion parameters, and I'm very good at mistyping things on the command line editor, or on the command line when I'm trying to like do it manually. Although these notebooks are kind of nice because then you can just like construct your command as opposed to trying to like enter it in perfectly the first time when you're doing it, because I find I don't do things perfectly the first time. So it's llama cpp /main is your main command, and then so we want to we'll probably start with a prompt as opposed to doing interactive first, because doing interactive with this Jupyter notebooks are kind of weird. But what we'll do is we'll launch a chat bot in a server after we do the first couple interactions with the model. So as we go down the list, we see there's interactive, so that's one we'll use later. We want the instruct model, so double dash and then instruct, or dash, single dash and ins. And then we want a prompt. So what do you want to say to the model? You can say whatever you like, and then make sure you put it in quotations. I usually ask it to tell me a little bit about itself, because I'm always curious as to if it's aware it's an AI or not. Sometimes models, when they're untrained, they'll start babbling nonsense. It just means that they need to be trained on the chat, like the chat format, because it doesn't know that it's in a conversation. So it's just like randomly, it's basically just hallucinating and randomly outputting stuff. So it'll tell stories about itself and stuff, and it's just like really random. So if that happens, that just means you need to do some fine tuning. This model, I believe, should be fine because it's the instruct model, which means it's already been trained for chatting. If you want, you can put on the color. I like having it on. It differentiates between the chat and the user when you're working on the command line. And then threads. Let me see here. How many people do we have? 8. 120 cores divided by 8. So everyone gets 16 threads. So T 16. I'm not sure what the number of threads to use during. Does anybody know for threads batch, like how that works? I believe it's like for parallelizing, but I never know. I usually just wind up putting it as the same amount as the threads, but I feel like that might not be optimal. If anybody does know that, then let me know.
I have no idea.
Is this the batch inference you're talking about, or?
Yeah, so it's thread. There's threads, and then there's threads batch.
I think it's basically the GPU memory decided by how much of parallel processing you want to run through it, how much of throughput you're expecting through it. So it's a factor of that.
Okay.
So if you want to kind of have an SLA, right? If you have, say, 300 or 400 requests, you can only go through 16, I think. That's what it refers to. I may be wrong, but I think that's what it is.
Okay.
Because it wants to pack the GPU with all the batches. So.
Yeah. So, okay. Well, I usually just wind up setting it as the default for it is to be the same number as threads. So I just basically do that. You can like really spend a lot of time sort of tweaking these settings to try to get like optimal settings. And I've found that it is very time consuming, but also sometimes rewarding, depending on what you're doing. Like, for example, there's another library called Whisper CPP that's very, very similar to this one. So if you learn how to use this one, you can use the Whisper one, which does text to speech, or sorry, speech to text. And that one can run like on almost anything. Like it runs really fast. But I managed to get it working on a TPU, and when it was working on that TPU, it did an hour worth of audio transcribed in about 30 seconds. So
whoa,
you can, yeah,
that's impressive.
Yeah, it was crazy.
That was the still version or the fast version?
Which version?
the distilled version.
That was the non-distilled version before distillation was popular.
Seconds. No, what?
But I was using a smaller model. If you try to use the bigger models, counterintuitively, that I found that they didn't actually work faster. They worked a lot like you'd think that like with a TPU you'd have like so much room on it or whatever that you can just like go ham with it. But I found it actually ran the smaller models a lot faster if you I guess it's just because it's like limited amount of throughput. Anyway, so then the next things are escape characters. So if you want to actually use escape characters yourself, prompt cache. This is if you want to have like a long-term dialogue. So it's kind of like a context menu. Or sorry, context window. So one of the things with these models is that they don't inherently come with a context window, which is very annoying when you first get them out of the box because they literally won't remember the last thing that you said to it, even though it's in the same chat window, unless if you send that in the context of your next message. So this library is taking care of a lot of that for you. I was going to do it where we would have our own chat window and stuff and like do all the coding for it and whatnot. And then I was looking at it and I think it was going to take too much time because I think this is already taking a fair amount of time as it is. And then after that, we have you can randomize your prompt if you want. That's more for like benchmarking and testing. And then you have a lot of different fine-tuning optimizations for like your BIOS and stuff, and how to set up the prompt. You can select how many tokens that you have. You can select your batch size, and then you can also select your samplers, and then you can select all of your standard like ML options as well. We can just keep everything on default for the most part here. It does support grammars as well if you want to constrain the model with grammars. You can put in negative prompts. There's a CFG scale, which basically is sort of like how creative the model is, I guess, is the way that I would put that. Does anybody know exactly what that is?
Not familiar with it myself.
It's CFG. Oh, go ahead.
I'm familiar with you can change the temperature on your softmax, and maybe
Right.
they just named it CFG scale to be similar to when you do image generation.
That's what I'm thinking, yeah.
But there is no classifier-free guidance that I know of for LLMs.
Okay, that makes sense, yeah. And then there's a bunch. Oh, go ahead.
No, I'm thinking the creativity could it be like kind of like how far kind of like the parameter range that you can generate from.
It was a little bit muffled. I'm sorry, I didn't quite catch all of that.
Okay, never mind.
No, that's okay. Maybe put it in the chat, and I haven't been actually looking at it. Yeah, and then so there's like a bunch of different like I said, there's like a million settings on this thing. Let's just we could just run it as it is now with the default settings. So then we also want to set the model. So M is the model settings, and then so you'll want to do / and then it should be the Mixtral experts, and then / and then I think it is, which one is it? It's gonna be one of these guys. I believe it is the first one of the binaries, but I'm not positive, so let's find out. When in doubt, run the code. If anybody knows where that's from. All right. So then we can set the model. And then I think that's the only thing that really matters right off the hop here. So we'll just give it a go. So try and run this out and see what happens.
Uh-oh.
Failed to load. Am I done downloading it? That's the question. Looks like I downloaded it. Oh, we need to convert the model into a GGUF. I forgot about that. Sorry. So we'll add a new cell above this one, and then we will I try to keep things in order of when I did them, because if I don't, then I'll forget what order I did them later on when I come back to the script, and then it will be I'll wind up running into the exact same problem again. So if I like organize it now, then I don't have to worry about it later. So we'll do gguf or gguf, and then I'm just going to run that as it is because I just want to see what the help is on it, because it will tell me exactly how to load it. Oh, it will not, maybe. Let's see here. Then it must be in scripts. So let's take a look in the scripts. So if you go into the Llama CPP and you look into the scripts, there's like a bajillion scripts as well. There should be one that says convert to gguf.
Convert GG.
Dash
Up,
GG.
right there.
Yeah, that one. So we want to run this guy. So let's look at this. So Falcon code llama. Llama. Set environment. So we're running convert.py basically is what's going on. And it looks like it's convert.py, where the model is, and then the output file. So we can just run that command. So we'll do llama cpv slash scripts slash convert. What is it? Convert. I have the memory of a goldfish. gg.sh, and then you put in the model position. So, and then model. And I can say tensors, and then the output you can put in as Mixtral 8 times 7b struct, and then dot gguf, and we'll have to put this in llama.cpp, and then we'll put it in models like that. So I will try that out, and hopefully it works. Not open repo, no such file or directory. Okay, so this is because I'm in the wrong folder. I should be inside of the llama cpp folder, so we'll have to cd down into it and then run that script, because the pathing is being finicky about where it goes. So I'll modify my script like that, and then try.
So for your output, do you want to no longer have the /llama cpp? You want to just do /models?
Oh yes, you're right. Thank you. Correct. And actually, for the model, I want to do ... to get to where the model is. And I think that should work. No model named sentence piece. Import sentence piece. So it wants sentence piece transformers. So sentence piece transformers is an NLP library. It's very common for tokenizing. So we'll do pip install sentence piece. And then we'll try this again. No such file, llama 7b. I wonder if this is not going to run the training for. Let me just look something up real quick here. I should have thought about I forgot about having to convert the file before this, unfortunately. So this is basically how all machine learning works, is you just spend lots of time looking up things and figuring out how to solve problems. So you're getting the real deal. Let's see here. Might just do.
I think I did it.
Oh, you got it?
I will share my comment. Let me.
Yeah,
Wait.
great.
wait for it to finish because it's taking a long time.
Yeah, it'll take a minute to train the whole thing because it's not super duper small.
Yeah, I did it on the terminal, so it doesn't let me just copy the command.
Yeah, no
So
worries.
I will wait for it to finish.
Just wait
so
for
I
it to finish. And then once you're done, we can just it should appear oh, we can just copy it into everybody's folder too. So which number are you on?
I am number 2, but let me copy this.
Ah, yes, I see it here. So then we can do, let's actually just put this into the other folder. Oops, I don't want to open that. No, that's really big. Don't open that. So just let me know when it's done. Okay, and then it looks like it's finished almost. I guess I can do top.
David, were you down in the Llama CPP directory when you? No, you weren't.
No, the directory I use is model Mixtral GGLM model F16. I share in the chat. I put it in the chat.
Yeah, so is it the same all three of those? Model Mixtral.gguf. So that's for that. And then so that can go there. Okay, so let's grab this guy, and I'm just gonna. Is this model done training? Keeps growing bigger. Oh, I know. I can just check the video. How are we doing? Looks like
It's
it
3,
is
right?
done. Yeah. So then I'll just move this into the other folder so that everybody can have access to it. So put that there. Boom. All right. So now when we try and run, we'll go back to the bottom of our script where we had the model here. We're going to want to put in, what is the path to that now that I think about it? Okay, so it'll be dot slash Mixtral struct and then slash ggml model dash f16.gguf. And then now when we run it, theoretically, it should talk to us. To return control without starting a new line, and your input. If you want to submit another line, enter with slash. So let's see here. Are we using the GPUs is the question. So I've done this before where I've wound up not actually using the GPUs. Yeah, like right now. So it's just running the model on the CPU. So I gotta figure out what the settings are gonna be to get it to run correctly with that. I'm gonna look at what you did over here. Out file, out type, Python 3 llama CPP convert. Okay, so that's not it. And then where are the instructions for this thing? It's all right here. Export CUDA visible devices equals 1. Yes. Yeah, make sure that that export goes off because we don't want to all load into the same GPU. Threads. Where is that? I need to like explicitly tell it what devices to use, I think. It's one of the problems with having so many settings on this is that it's very not straightforward all the time. Parallel, sequence. Attention, catch type, control vector, model depot, login file name. a sec here. I'm gonna go look at the repo. In the interim, you can try and run that command to see if you can train a model, because that appears to have worked. Or quantize the model, actually. That's what that GGUF is doing, is it's quantizing the model and making it into a floating point 16 floating point model, which means that it takes up less memory and can run on smaller or less high-end hardware, I guess is the way that I put that. So let's see here.
So you went for 16-bit, is that correct?
Yeah, so it's in 16-bit.
Okay.
And then we can do chat. There's a number of examples that are useful. Maybe we can do this one for now. Server model threads rope. Okay. So I think being constrained into the notebook is not as exciting as actually talking to a chatbot. So let's talk to a chatbot. We'll kill this one. I'm gonna kill this process because it's running on the. There's a lot, like the CPU is pretty powerful on this thing, but it's not gonna run that. So then if we do cd llama cpp /server, and then we do help. This one has a lot less settings and is definitely easier to use. Oopsie. CP and server. There we go. Elements. So I use this server all the time. So we will do threads 16 thread match 16 as well, and then we can do number of threads process parallel and +2. Can't read that properly. Threads batch n those threads, so that's fine. Default max hardware concurrency is -1. So let's do that. So you take the threads HTTP and then put -1 for that, and that should theoretically use the maximum hardware capacity on it, which will fill up the GPU. And then I think that's basically all that I care about. Context size, we can put at 1600 or 16,000. And then model name going to be // Mixtral, the GGUF model. Then everything else is for training. Call that do a port, and then we want the port to be. Oh, let me think about that. What port do I have available? Oh, you do the port as 8080. I guess only one person's going to be able to have the chatbot up at a time, because I didn't think about networking for serving it externally, unfortunately.
Well, if you just demo it, it might just be good enough, you know.
And then
people can do it on their own.
And I can leave these instances up for a little bit if people want to use them as well. So.
Oh wow, that's really going above and beyond.
Failed to load model. Unable to load Mixtral model. Why does it not load?
I don't think you're in a models subdirectory anymore. I think you just put the GGUF right in the Mixtral directory, didn't you?
Yeah, I did. Oh, but I went down another level, so I think this is what it wants. Nope. Okay.
Can we just do
So
it
after
PWD?
your 8x7 blah blah blah, you have /models/Mixtral. I don't remember you ever.
Oh yeah,
having
you're
this
right.
one. Just
There
right
we-
there.
Yeah, there we go.
Ah. Good memory, Ted.
All right, now that's actually running. So then, that's basically how easy it is to get the model up and running on, like with this infrastructure. Where's the scrollable elements? Let me see. Yeah, and then we need to. It's on 8080, so then I can go to localhost 8080, even though it's not local, but it is local. Theoretically, there should be a chatbot, which there's not, but that's because I'm on Tailscale. How do I get access to that without showing everybody all my IP addresses? Hold on a second. Tailscale. Let's just go through the browser.
All right, everybody close your eyes here for
Yeah,
30 seconds.
that includes you at home watching on YouTube.
Yeah.
Going by the honor system here.
Yeah.
H100. I mean, I don't think it would be a huge deal because it's a weird, crazy Tailscale network. My DevOps guy is always raving about how much he loves Tailscale. It basically treats everybody like you're on like the same network. Let's see if that works. Bard. Nothing ever works. Function time slot.
David had a point because of the Docker thing. You may have to redirect it, right?
I'm not in a Docker instance, so
Okay.
it should theoretically just go out. Well, that's annoying. Am I running the server one? Maybe I'm not running server. Yes, I am running server. Okay. So what is going on? Thinking. Do we need to create a Mixtral directory under Llama CPU models before we can list it as an out file location? If you want it in a folder called Mixtral, you would want to have. I think it will actually make the folder. I'm pretty sure it does. So no, you can just put in the path, and it should theoretically just save it automatically to that path. Oh, maybe I have to put it on server -t-v. I'm missing one setting. Why doesn't everything go perfectly all the time? Let's see here, which one am I missing? Oh, it's still running this one. Okay, let's just kill this guy for now. Boop. And then run this guy again. So it is rope scaling. No. I think it's like host or something that I'm missing. Chat Gingin template. That's new. Default template taken from model metadata. Oh, that's the talking. That's the prompt meta template. Where is the ports? Predict group. Function file name. There's port and then public path. So it's these three that I want. Okay, so let's do this again.
I know what is not working with CUDA.
Why is that?
You remove the flag llama CUDA equal 1 when making the
Oh, making the binaries. Yeah, but I still have been able to get it to run with the GPUs. It just does. It's just not CUDA accelerated. Which means it's like slower, but it's not like super slow. If that makes sense. But you could be right. We could try and rebuild the libraries, but then we have to play around with fighting CUDA for the next little while.
Yeah.
And at this point, I feel like we're like, yeah. So path for which sort of static files. I don't care about static files. And then I just want the model. So it's dot / Mixtral / ggml. And then what else is missing? So the port, and then I have the host. And then I think that should be enough to go. I don't know if the threads. 16. There's 32 for that one, I think is the right one. Nope, it's upset. Usage.server options. CD mono CDB, and I'm really not used to doing this on this, so I'm just gonna run this here. Oops. Give me the same things. What? It's not giving me an error message. That's annoying. Server.
Yeah, just
it just says this is the usage options.
yeah.
Gonna run, thanks. Yeah, that's fair. It's all train wrecking at the end. But what are you gonna do? Yeah, so theoretically, this is how easy it is to get your language model up and running.
We got right to the finish line there.
Yeah.
Are we there yet?
Yeah, no, I think I'm just gonna call that there. So
Okay.
that's two for two now. But yeah, so
Well, it is typical of a live demo, right? So don't feel too bad. We've all had this happen, so.